is a fab lab, and it's a space for grassroots and bottom-up research, promoting strategies that relies on community engagement to develop projects. And of course, it's also a prototyping platform, meaning a digital fabrication facility open to people. Opendot is founded also by ... which is a 12 years old design practice, researching and focusing on design and technology. So the talk of tonight is part of a wider program called Machine Learning for Artists Workshop, which is a one-week workshop held by Gene Kogan and organized by and hosted by Opendot. And basically the workshop put it together, more or less 30 people coming from many cities, from Milano, of course, Roma, Turin, Como, Bologna, and then Prague, London, Bristol, Berlin, and Frankfurt, and I think I've said all the cities. And for 1 week, more or less, we have this 30 people, 50% of them with technical background, 50% with a creative background, working together in order to learn machine learning and to develop creative applications through projects using machine learning. So it's not an easy task, but we're having fun, so we're keeping working until the end of the week. And so basically, now introducing you Gene Kogan, who's the tutor at the workshop, and he's an artist and a programmer from New York, currently based in Berlin. And Gene is interested in generative system, artificial intelligence, and in general softwares enabling self-expressions. And so in general, Gene works on many environments like sound production, installations, new media art in general. At the moment, is very, very busy in promoting artificial intelligence through educational formats, like the one Machine Learning for Artists. It's very interested in democratizing this technology to people for many different purposes at the end, like activism, art, design, and so on. And I think that they're gonna grow this list perhaps. And so I made several residencies in New York, like at ABEAM and ITP. And at the moment is working also on a book titled Machine Learning for Artists that is gonna be an online resource, open source resource, that is gonna be ready by the first part of 2017. 2017 for sure. And yeah, I think that's perhaps enough for introducing Gene. And so enjoy his talk.
Cool. Hello, everybody. Thanks for. Thanks for braving the rain. Is it still raining? It's been raining all week since I came here. So if it is, thanks for coming out. So yeah, my name is Gene. I've been here since Sunday. This is the third day of our workshop here, called Machine Learning for Artists, and it's been kind of this workshop that I've been iterating over most of the last year. I'm going to kind of show you some of the resources we've been developing here and online, which Sabina mentioned, ML4A, which is something that I'll talk to you guys and hopefully get you guys excited about it. And all of the stuff you can find online. I like to kind of share things pretty publicly and as I go, even things in progress. So I'll just tell you really briefly about myself. I have kind of a dual background in what's called music information retrieval, which is this field of machine learning applied to audio. So things like figuring out tag words associated with music or sound, field recordings, things like that. Getting things like genres and tag words, and doing more like musicological stuff like decomposing audio into chords and melodies so that you can drive sort of lots of online services. This is the kind of stuff I used to do more in a past life, but for the last few years I've also been a practicing new media artist, or what's usually called a new media artist, which is things like this kind of stuff, making installations and into more interactive stuff, working with generative art, using a lot of what are called creative coding platforms that a lot of you are probably familiar with, processing and open frameworks, especially. And I'm always trying to kind of inform these two practices with each other, trying to take what I know from what I know about data science and apply it to making interesting new media art experiences, and then vice versa also, trying to make data science and machine learning a little bit more approachable, both approachable and kind of more fun, exciting, and expressive for people, so that they don't feel like it's just this dry scientific topic for engineers to work with, but it's something that they can find to be relevant to the things that they're interested in. So I'm just gonna start by asking this question: if you put like googly eyes on one of our robotic overlords, these killer robots that we're hearing a lot about these days, do you feel threatened by it anymore? So this is like a weird animatronic baby, and it doesn't really have anything to do with anything, but just to put in a light bit of humor about the singularity, which is something that everyone hears a lot about these days, AI and machine learning, and all of these things have become a lot more talked about in sort of mainstream publications, in universities, a lot in the last couple of years, and there's kind of good reasons and bad reasons for that. The good reasons are that we've made a lot of really exciting progress in the field, and the bad reasons for that is that there's always a lot of people that would like for other people to not really understand why or how this stuff works, which has really been kind of the motivation for this workshop. And I'm going to read you a quote by Marvin Minsky, who was one of the really early pioneers in artificial intelligence before anyone had heard of such a thing as machine learning. Marvin Minsky, who just died recently, actually just a few months ago, and before anyone had heard of the singularity, when people had first begun speculating in the sort of 1950s and 1960s that maybe we'll build robots that are smarter than human beings and will eventually sort of take over the Earth for us, he asked the question, will robots inherit the Earth? Yes, but they will be our children. And it's a little bit, in some sense you can think of it as a kind of a naive thing to say, but the question would have made, the answer would have made a lot of sense to him back then, because for him, he understood, the gears that were in his hands, and we hadn't really gotten to this point of really sort of overhyping a lot of the technology that we were building. And in some ways, I'm always kind of like, I can understand why people have so much anxiety about this stuff, because AI has really been in the news a lot lately, and not always in a good way. And I'm gonna just read you something from research circles that emerged literally just this past week. So about 1 week ago, and I always love to keep these as current as possible, there was a paper that emerged from a university in Shanghai doing some work on machine learning, in a paper called Automated Inference on Criminality Using Face Images. So what this paper was trying to show was that you could actually predict whether someone was going to become a criminal simply by images of their face. And if you read the paper, the first page says, although there's been a lot of controversy in this field in the past, we show that we can actually really accurately do this. And then they go on to not talk about the controversy at all. But they do say that they can find sort of markers on people's faces that indicate that they may become criminals in the future. So they find so-called discriminating structural features such as lip curvature, eye inner corner distance, and the so-called nose-mouth angle, which is over here. And it's pretty scary. And actually, but the thing is that this has a pretty long history. This reminded many people who were in this field and who know a little bit about history about a book that came out not too far from here, about 130 years ago or so, called L'Uomo Delinquente, which was written by Cesar Lombroso. How many people know this guy? Who's lots of, okay, I'm not surprised. So Cesar Lombroso was a physician, and a criminologist in the late 1800s. He's from Verona, so not too far from here. And he kind of rejected what was known at the time as the classic school of criminology, which kind of hypothesized that criminality was a behavior that was learned. It was part of human nature, that it was kind of a result of your circumstances. He rejected that, and he thought that people would simply be born criminal, and that you could identify criminals from birth almost by certain structural, facial characteristics. And he drew a lot of these sketches of people that were criminals, and he said that you can identify criminals by various sort of facial features, steeped eyebrows or steeped brow, and like hook nose and all this kind of stuff. So this goes back a long time, and people get a lot of anxiety for good reasons. We've been hearing a lot about AI in the news and other capacities as well. So lots of you have probably been keeping up to date with the recently passed election that we had in the US. And one of the things that was really prominent, actually, that people began to talk about, I think probably for good reasons, was the effect of social media on people's public opinion. So Facebook has been a lot in the news lately. And also not for good reasons. We know that in America, 50% of people get their news from Facebook, and like primarily from Facebook. And Facebook uses all of these machine learning algorithms to sort your feed so as to kind of keep you in this sort of echo chamber, what we call sometimes in somehow a pejorative sense. And for good reasons, it keeps you there. If you're always finding stuff that reinforces your views and keeps you in this sort of bubble, you're guaranteed to keep reading Facebook. And they got in hot water a couple of times, including this picture up here where they censored an iconic photo from the Vietnam War because it included a naked child kind of running through streets trying to escape a napalm attack. Pretty iconic photo. Lots of people know this photo. But it broke sort of Facebook's terms of use, and this became quite a bit of a controversy. And so, this is just one of many examples that we've heard a lot about with Facebook. Another thing that's been pretty prominent in the last couple of weeks has been fake news. That's another thing that we've been talking a lot about, which I think we should be very cautious about, because right now many people are now trying to push Facebook to sort of monitor and remove fake news, which isn't always very obvious what that is. And it's not always fake news that's the problem. A lot of times I think it's kind of real news, which is presented without context or without supporting information and so on. So it's kind of a complicated issue, and probably requires a lot of oversight and a lot of knowledge about maybe how these algorithms work a little bit, which will kind of help, I think, inform the discussion. These are just, I'm not going to talk at length, but because this is kind of for a much longer talk, different issues that are associated with AI. There's another example of criminality prediction from an article from a really nice journal called ProPublica. I'd encourage lots of you to look this up. What do we do about this? So for my own part, I've been really interested in promoting a greater understanding of the principles of machine learning from a scientific perspective, from a scientific and engineering perspective, for the last couple of years. And the reason for that is I'm not really sure what the answers are in a lot of cases. We have questions like, okay, how do we monitor this content? How do we use machine learning when there are actually tangible benefits? Like it's not necessarily the case that machine learning can't be used in these domains, like trying to predict when someone might actually do something violent. That by itself, in and of itself, is not necessarily wrong. But what's wrong about it, I think, is when nobody understands how it works and and we are not in a position to kind of make informed, democratic, consensual decisions about how these things are integrated into our services. And most people don't even realize how much machine learning actually affects them. I mean, if you read Facebook, or if you're participating in social media, then it's obvious enough. But even if you don't, a lot of that stuff is affecting all the people around you. And machine learning is in almost all of the machines that we use these days, not just social media and websites, but certainly also in cash machines and in ATMs and financial transactions, and financial institutions are using machine learning all the time to make these sort of nanosecond transactions that can sometimes actually almost bring down the stock market with them. So it's not obvious to anyone how this kind of beast that we've created works. And so when a very small cohort of people understand how it works, we're in trouble, right? So for me, the way that I've been trying to combat this is through what is an in-progress resource, which Sabina alluded to, ml4a.github.io. I'm going to show you this website a little bit, which includes a lot of resources that I'm hoping will kind of make it a little easier for anyone really who's interested in the topic to come to understand more about machine learning. It's a website which, at its most accessible layer, is a book, or will be a book, which is nowhere near completion yet. But I'm going to take you through some of it. So it looks like this. If you go to the front website right now, it'll just say that go away because it's not done yet. But actually, you can just click here to the draft chapters, and you can see this book as it's in progress. So there's not really any sort of release. It's more ceremonial when it's actually released. It's really just a matter of it being in the state of the most accessibility. So it'll have a bunch of chapters that try to introduce the science and the technology and kind of the sociological implications of this technology as it gets integrated. And for example, the neural networks chapter will start with an introductory to neural networks. And neural networks I'm going to talk a lot about in just a few minutes. These are sort of the standard algorithms for performing a pretty big branch of machine learning. They've become really successful in the last few years for reasons that I'll get into. And they're really actually not that hard to get into. The math behind them is surprisingly easy, if you've seen algebra before. And but the idea here is to kind of make it something that doesn't assume so much prior knowledge in computer science or in engineering. It's just kind of something that most people can get into if they wish to put the time into it. It has these sort of interactive demos that are embedded into it. So for example, this will show you a basic, what's called a forward pass, which shows you how a neural network kind of propagates information, really kind of starting from scratch, from the ground up. And if you go through the chapters, a lot of these are just interactive demos embedded into it that help you understand it and kind of engage with it a little bit closer. But also, like, subsequent chapters get into more detail about what's inside these neural networks, what information do they carry, and starting to hint at more artistic stuff, which is going to be kind of what I emphasize. And there's a reason why I emphasize artistic and creative applications. And it's not because I think everyone should be an artist, but because I think these things are the most approachable. The way that people can really feel like, if you're going to use this for yourself, what is the most fun thing to do with it? It's to use it for self-expression. That's kind of the way I wish that we would orient all of our technology, to the extent that it's possible. Now with machine learning, there's a whole lot more, of course, but maybe if this is a good entry point. So let's call it a gateway drug, if you wish. So these are the chapters. There's also, I mentioned these demos that are included in it. So for example, like, you can look at something called a confusion matrix, which is something that's often seen in very typical machine learning packages. And this is a confusion matrix, shows you classification happening, image classification. So trying to predict what this image is of. So these are all, I don't know, you probably can't see these very well. But there's a data set of airplanes, automobiles, birds, cats, deer, dog, frogs, horses, ships, and trucks. And you can kind of investigate the kinds of mistakes this neural network makes. So for example, here it predicted a cat, but it's actually a bird, and you can see what all of the actual mistakes that it made are. We can be a little more fair to our neural network. These are actual cats, let's say. So things like this are included in the book, and then maybe the most involved resources are the guides, and these are kind of code samples and write-ups of different sort of practical techniques that you can use in machine learning. We've been using a lot of them through this course, and I'm going to show you some of them actually. So, as I said, I've been iterating this workshop over the last year as the sort of demand to learn machine learning has become, more pronounced. I've had a lot of help, a lot of participants, former students, really getting involved, making applications, not just the sort of traditional kind in Python and machine learning environments, but also within creative coding environments like open frameworks. Things that kind of let you make music and make art and do all sorts of, let's say, more fun things, more approachable things. We've been having lots of workshops as well. I've organized a few with Rachel at School of Ma here in Berlin, which this is actually, well, actually, this is not in Berlin, but this is one of the workshops that we organized. I've also, we had a machine learning for activists workshop, which is secretly mostly the same, but is oriented a little bit towards, sort of critical issues and things that might be of more interest to journalists, which is another group of people who are becoming increasingly interested in the science of machine learning, trying to sort of apply it to their craft in the process of newsmaking, because journalism is becoming really, really much more computational. In recent years, there's been a lot of new sort of data journalism and computational journalism programs popping up at universities, and it makes sense because information is all over the place, and there's really no such thing as being the first to a news story anymore, because everything is so public. And so really the real news stories are buried in plain sight in some sense, in the sort of troves of data that we're aggregating on a daily basis, which is pretty hard for anyone to actually read through individually. So you kind of use computational means to make sense out of it. I also record a lot of my classes, so I'm actually recording this talk right now, so creating a screencast that'll go online later. And so all of this stuff is online, so lots and lots of hours. If you go to the classes tab in ML4A, you'll see all of that available. There's 2 up here. Right now there's going to be, this class will also go up here when we're done next week. And all of the code, literally all of the code that goes into this website is on GitHub. So for those of you who are coders and want to get more involved, you can clone the website onto your computer and run it locally, the entire thing, and make changes to it, more or less do whatever you want, and hopefully contribute. So this is a field that no one person can possibly keep up with. So in the future, I'm hoping to create more features of the website that make it easier for it to become kind of more decentralized and more open to contribution, and that's going to be a long process, but hopefully sometime next year, I think you'll see some features like that come up. Okay, let me just show you a few more of those resources, and then we'll get to some eye candy, which will, no machine learning for artists talk is complete without some eye candy. So, some of again, a few more of the resources that have been going into these classes and been going into the demos. Going into the website have been these kinds of demos. So this is a visualization of a neural network as it's learning how to identify images of handwritten digits that people make. This is kind of the classic hello world task of machine learning. And what's interesting about these is that you see, if you visualize the internal state of the neural network, it looks as though it's learned these kind of templates that look like the numbers themselves. And we didn't ask it to do that. We didn't tell it, what the digits are, what they mean. It learned how to represent them because we gave them lots and lots of pictures of them, just images, raw pixels. And this is kind of a hint of some of the really interesting properties of machine learning and why it's become so interesting to visual artists, is that they're learning from data how we see the world, right? These are all sort of glyphs that we created, and neural networks are these algorithms which are able to come to represent them just simply by being exposed to many examples of them. And it becomes a little bit more clear why this is useful if, camera's not working, okay. it becomes a little bit more clear if we look at this kind of demo. So here you're looking at a neural network which is being processed live in my presentation. And what it does is, this is called a convolutional neural network, and this is sort of the standard bearer of most of the exciting progress that we've made in machine learning these days. And what it does is it's forming this sort of layer by layer, progressively high-level representation of what it sees. So at the first layer, it does something really, really simple. It uses this mathematical process called convolution to take all of these sort of small filters, or what we call feature detectors. They're kind of looking for edges or small patterns or gradients and things like that. And when you convolve them with my webcam image, you get all of these kind of responses that all look slightly different, but you can kind of see me in them. They're all looking for different kinds of edges or gradients. You see that some of them respond more to like sort of horizontal lines, and some of them more vertical lines. Maybe this one is sort of like left edges on the left side, and others are edges on the right side, and so on. And that by itself doesn't seem so interesting, but it becomes more interesting when we do another convolution on top of what we just learned in the first convolution, these edges. When you combine these edges together through another round of convolution, you can learn things like corners or grids, or really somewhat more complicated, still low level, but kind of more complicated features inside of the image. And they may look like this. And it becomes progressively harder to interpret, but it'll make a little bit more sense at the end if this is the kind of thing that I need an hour to properly explain. But in a very short second, I can tell you that if we do this process of convolution repeatedly, what ends up happening, which is very interesting, is that it learns much more abstract features. And I'll show you one of them if I can find it, because it's always hard to find. I think, this one, yes, 156. This one, if you kind of look at 156, it looks as though it's lighting up for my face, right? So I kind of move my face around, and it moves with me. And you can tell that it's my face and not like just skin, because I can put my hands over my face, and it disappears, right? I can't tell, because I think it disappeared, right? Yeah. So that's pretty interesting. The neural network doesn't know anything about faces. We didn't ask it to find faces. But in the process of learning how to represent all of these different classes that we fed it, it became really able to understand faces. And so now it does. Now the cool thing is, once we have this high-level representation of faces and wheels and I don't know, doorknobs and windows and things like that, it becomes much easier to classify what's inside the image. And this is the technology that's really kind of the flagship of what's called deep learning these days, is image classification, something that we've become way better at doing over the last 3 or 4 years. We used to be quite bad at it. You can do it at the end with this trying to predict exactly what's here. Neck brace, of course. Let's see if we can find some examples. Does this keyboard come off? Let's try. I always try new things. Okay, let's see if it recognizes what this is. Computer keyboard, right? Not bad. Does anyone have any other objects we can try? Oh, yeah, okay, yeah, that's right. We did this the other day. So it likes the teapot. Coffee pot. Yeah, not bad. Espresso maker. Look, I can't tell them apart, yeah. Of course, it only works on things that it recognizes. It doesn't have unlimited vocabulary, but it does know a lot of things. It knows 1,000 things, actually, in particular. But really, the most important part about this, and you'll see why in just a second, is actually the thing above. This sort of, you see this grid of pixels? That's the layer of the neural network right before we do the classification. And it's this sort of like high-level feature vector, which means it represents the content of what's inside the image, but it's sort of high level in the sense that it carries much more valuable information, like the presence of these different important features like faces and windows and I don't know, doorbells and things like that. who knows? A lot of them are less interpretable than others. But the reason why the features are valuable is that they tell us a lot of, it's like a vector which represents the image and should be similar to other images which have the same content inside them. So if you've ever used like Google's reverse image search, for example, you know how you can upload an image into Google Images, and then it'll give you back a bunch of images which are similar to that image. And the way they work is using that feature vector, right? The one that we just saw in the encoding, the top bar there, the flowers. So like this flower, for example, these are a bunch of images which resemble that flower, and they may have even very different colors, like this purple one, but we're able to still find, based on high-level abstractions, like this is a flower, what similar images look like, what similar images to it are. So for example, like here's a spider, and here's all these other spiders, and they may be in all these different orientations, or have different colors, or be cluttered with other objects. But even still, it's able to kind of identify the high-level properties of spiders. And this is basically how Google reverse image search works. Hummingbirds, dinosaur skulls, and more flowers, of course, and lots of these. So this is the kind of thing that you can do with machine learning and kind of use it to work with data, do things like organize images, and actually that's going to be some more of the next focus here. You can have a lot of fun with neural networks also. So this is one of the things that I've been doing as part of a lot of my workshops, is teaching this piece of software called WekaNer. It's made by a researcher at Goldsmiths in London named Rebecca Fiebrink, who made this basically a tool for musicians and artists to engage with machine learning. Started working on it, I think, in 2009 or so, 2010. Really before there was so much interest in this from the arts community. And what this kind of does is it lets you approach machine learning if you're a musician, let's say, and you don't know how to implement neural networks, but you do know how to play electronic music or work with connects or sensors or things like that. And it lets you kind of create mappings, create neural networks which learn mappings between, let's say, your face, like that's me actually, with the face tracker, and I'm controlling the parameters of Ableton Live, which is this software that's used a lot for making music. Really kind of making this a lot more fun and approachable, which is, as you can see, kind of a theme to a lot of what I like to include. And this is actually another thing that you can do with WekaNer, something called transfer learning. So here I'm using the same convolutional neural network that we just looked at to make a program which can tell apart a coffee cup and a croissant, which is pretty silly, but it's amazing that you can do this with really, really quickly. And I have demos that show you how to do this in literally just a few minutes. You can create a classifier that'll tell apart whatever you want, kind of working with this software. And let's say making use of these really powerful tools that you can download online, convolutional neural networks that you can just download and run in your computer. The tools have become way more accessible in the last couple of years, which has been really interesting for me to watch. And what's next? Tsni. So Tsni is another organizational tool very closely related to the reverse image search. So here we've taken all these images of animals, and we've kind of had a neural network, oh, that's an ugly part, right? Put them all together. So similar ones. So for example, here's a dog section. And over here we have, I'm always finding something new every time I look at this. Zebras. Here's our zebra cluster. There's a unicorn cluster in here somewhere. I don't ever fully remember. Oh, there it is. There's the unicorn cluster. So here all of the unicorns are in one place. Who would have thought, right? Whales and so on. So this is a technique that does this, that creates these layouts automatically by using a convolutional neural network to analyze the images and then use Tsni, which is this technique that's emerged in the last couple of years that's really amazing for visualization. It takes high dimensional data and it compresses it to 2 dimensions so that it can lay it out on a 2D grid. So you can do that with images. You can also do it with text. So I'll show you this website. Actually, it's on my website, called WikiTsni. So this is a a list of political ideologies that were scraped from Wikipedia. And you can use a technique in natural language processing called latent semantic analysis, which is used a lot in computational journalism, to create a feature vector which represents the article of text. And then in just the same way that you do with the images, you can then use t-SNE to embed it in 2D. So here are all these articles that we can kind of look at. So here's a bunch of like Marxism articles that have been clustered. Here's a cluster of nationalism articles that are all related. Who knows what else is here? There's there's a bunch of environmentalism articles here. I know there's a feminism cluster here at the top here. Marxism cluster. Marxism. Sometimes things are kind of out of place. Christianity articles are kind of clustered over here. So this is kind of a neat way of browsing Wikipedia if you're into doing that, as I am. And all of these are just links, so you can click into it and get the Wikipedia article about neoconservatism, among other things. And finally, and the most fun one is doing this with audio. So you guys know the song Bohemian Rhapsody by Queen? Is everyone familiar with that? Okay, most people. So you can use an algorithm from like music signal processing to segment that track into many, many different sort of small sound events, and then analyze those using typical sort of machine learning methods. Actually, not even machine learning in this case, just sort of signal processing. And then use t-SNE again on those resulting feature vectors to embed those samples in 2D space so that similar sounding ones are grouped next to each other. So we can kind of like browse this. As I move, you can see the mouse over here. So as I move the mouse over these, we'll play them. Here's the hard rock section. Let's look at this cluster over here. We found the piano. That's the solo at the end. I think that's when he keeps saying no, right? No. Really kind of fun way of making music. I'm sure you'll see a lot of tools like this and emerging in actual music making software pretty soon, because you can imagine how useful it would be for musicians that are working with large collections of samples and recordings, just as an assistive tool, if nothing else, to kind of manage large collections of media. So I think you'll start to kind of see this in more software if you do make music. So the thing that really caught everyone's attention last year, especially among artists, is neural networks sort of hallucinating images. And this has kind of been the weirdest thing to watch. And I'm going to show you just a few of these projects. And I'm going to kind of go in them in order. The first thing I'm going to show you is something called Deep Dream. Can you raise your hand if you're familiar with Deep Dream? So most of the people in my class certainly are. So Deep Dream was this this software that Google released last summer, and it was kind of built on some years of research in just more generally in the machine learning research community that was interested in using convolutional neural networks kind of in reverse. So instead of using a neural network and putting in an image and then it having predict what the image was, you instead would tell the neural network to create an image which would look like some class that you wanted to see hallucinated. So if you have a neural network that learns how to recognize many different kinds of breeds of dogs, then maybe you can use that neural network to put dogs into images, which is basically what Deep Dream became known for. So this is like a sketch by Leonardo da Vinci. Maybe some of you recognize it. He used to be a pretty prolific sketcher. And when you run it through Deep Dream, this happens. So maybe you can kind of see what's going on. Mostly dogs. These were nicknamed the famous puppy slugs, and you see they just kind of emerge from nowhere. They just pop up, yeah. And it's doing a very clever thing, which is that it's putting the image into a neural network and observing what's in it using all of those, what are called activations that we were looking at before in that demo. And then it's adjusting the pixels to make those activations that it found bigger. So whatever the neural network thinks it sees, even if it sees just a little bit of it, make more of it. And then you get these really bizarre images. And you can kind of make all sorts of weird videos with it. This was just some different videos that I made with the software after they released it. And it kind of has this aesthetic. If you were tracking the Deep Dream stuff last summer, you probably saw a lot of this stuff kind of strewn about on social media and so on. So I also was playing a lot with what are called deep convolutional generative adversarial networks. So say that 10 times fast. These were really, these are amazing, kind of, and they came from some researchers that were interested in making neural networks just spontaneously hallucinate images from data sets. Not modifying real images, but just creating completely novel ones. And these generative adversarial networks have a special property that you can kind of have it hallucinate between classes. So here, this is trained, these numbers here, it was trained on a data set of images of handwritten digits of images. Handwritten images of handwritten digits. And it learned how to spontaneously create new ones, but it also learned how to kind of interpolate between them. So get something that's literally halfway between a 5 and a 6. And I don't mean 5.5. I mean a glyph that's sort of halfway between the 5 and the 6. And it makes these really nice sort of smooth transitions. I applied the same technique on this project that I called A Book from the Sky, which was named from this really cool artwork from the 1980s by a Chinese artist who created all these fake Chinese characters, an artist named Xu Bing. And here I did kind of the opposite. I created fake versions of real Chinese characters using these generative adversarial networks, and you can see that it makes like really sort of nice transitions between the class. Finds these imaginary characters that live in between other characters, and you can kind of watch a few of them go by. This was a really, for me, like a very satisfying artistic project, because not only did I get to work a lot with machine learning, but I learned a lot about Chinese characters. I had a lot of help, I can tell you that. And one of the really neat things that I discovered was that Chinese characters are made up of what are called radicals. Radicals are these sort of root characters that is kind of a unique property of Chinese. And all of the Chinese characters have a history of sort of evolving from these root characters, of which there's, I think, 219, 204, one of those two. I forget exactly how many. And they all have a number. So this is like radical 30, which stands for mouth. So all of these characters have the radical sort of in them. And you can see that during the transitions, the radical, which I highlighted in red conveniently, is kind of preserved through these interpolations, which is a nice property. That didn't always work. I'm sort of cherry picking the nice ones, but it worked enough of the time that I thought it was interesting. This one is a little harder. So this one is the person radical, radical 9, which is really particularly interesting because, and this is something that's sort of lost in time, but people who research Chinese handwriting can tell you this, that the radical evolves through time and actually changes shape through many centuries of just being deformed by generations of writing people. And the person radical changes shape throughout these characters, but still kind of stays intact. So you see the red highlighted. All of these are, it denotes the person radical. Okay. My favorite one and the most recent one are deep generative networks, and this is some research that came 6 months ago. This is doing the same sort of technique, which was popularized a little bit by Deep Dream, which is class visualization. So visualize, what did we see before? Just like random. Well, we only look at Deep Dream, but that was working on class visualization, which is hallucinating these different objects. And this was some research done by a few people here. Made really awesome software that they released online that you can kind of use. This is a picture from the original paper, and you see that we're really getting into sort of uncanny valley territory. So you can see like the cell phone, aircraft carriers, entertainment centers, French loaves, lemons, lawnmowers, and so on. So this stuff is really, really, I don't know, looks pretty unreal for me. I don't know. I still can't believe that we can do this. And this is 1 year of difference, actually, from Deep Dream. So the field is moving really, really rapidly. And they use a technique that I don't have enough time to describe in detail, but you can find lots of information about it online that will be written about in the book and so on. So I'll show you just some work that I did with it. So here I took a data set of which they applied to called CafeNet. Sorry, this is not CafeNet. This is, yes, it is CafeNet. Okay. So this is all of these different image classes that you can have the deep generator network hallucinate. And you can see lots of them are sort of weird and don't necessarily look real, but lots of them are approaching uncanny valley. And this is kind of organizing them by similarity. So you see like the digital watch and the digital clock are next to each other, the projector, oscilloscope. So things with screens are basically in this region. Let's go down here. Let's see. Here's a bunch of sea creatures, electric rays and stingrays and tiger sharks, platypuses. Here's a goldfish, a bunch of different snakes, I think. Here's the dog section. These are some weird dogs. Nice pug. Again, I'm always finding something new every time I look at this. Let's go farther. Polecats, brown bears, fox squirrels, broccoli. Here's some birds. Brambling water ouzel. So a neat thing about this is that you can generate completely new image classes every time you stimulate the network. So here are a bunch of buttes. I think I'm pronouncing that right. We have lots of these in the western United States, if you've ever been out there. And there are these sort of canyon-like features. And every time you stimulate the network to create one of these classes, it would look different every time. And so this is kind of brings new meaning to uncanny valley, as I like to joke in a very cheesy way. These are people as they kind of come out through these networks, and they're pretty gnarly looking, I guess, right? So just these weird talking heads at conference centers. The nursing home one should kind of resonate. Lecture halls and golf courses. The basketball court. I can't tell if this is a head or a basketball. You can kind of decide. So one neat thing about these is that the way that it finds a class, so if you want to synthesize a particular class, it has to find the input to the neural network, which will activate this region of the generator network to produce that image. And you can actually animate the process of it looking through this generative space in order to come up with the class. So for example, if you want to find one, like for example, this cheeseburger, it will kind of jostle wildly until it converges on this perfectly formed cheeseburger. Very nice looking, right? And this one is a teapot. And there. So really lots of fun. This one's cool, boathouses. And the thing I like about this is that the network learns to memorize reflections in the water. So here you can see that, like, if you look at this, the boathouse appears to be reflected in the water. And here, you see more reflections. And this is cool because, again, this is knowledge that the network learned just by being exposed to many examples of it. We didn't tell it that water is reflective, or even that these pictures have water, or even what water is. It just learns properties of water from being exposed to lots and lots of examples. So these networks are learning things that we didn't really tell it about. Okay, wavenets. Wavenets is a very recent and really exciting work that was put out by a group called DeepMind, which is this really pretty advanced research company that's now it was acquired by Google a couple of years ago. They're pretty well known for making these AIs which play Atari games, and they also played the game of Go, which is something I'll mention later. But they have now been producing neural networks which produce audio. So they can synthesize voice with neural networks. So let me show you a sample. This is from their blog post that you can read. And this is a synthesized voice.
The avocado is a pear-shaped fruit with leathery skin.
The avocado is a pear-shaped fruit with leathery skin, smooth edible flesh, and a large stone.
Now, we've been able to synthesize voices for decades now, so that maybe doesn't seem so exciting. But the reason why it's exciting is that now we're able to do it using neural networks, which are simply given hours and hours of recordings of humans talking, and it learns by itself how to create voices. The way we used to do it before is by programming by hand these really, really complex programs which would literally try to completely simulate all the physical properties of the human vocal cords, which is, as you might imagine, is really complex and hard. And a major disadvantage of that is that doing that doesn't let you synthesize a guitar or anything other than a voice. So every time you want to synthesize a new instrument, you have to come up with a new physical model. Now all you need is recordings, and they learn all of the properties that are inside those recordings. So they showed how you can train it to create jazz music. So here it was given hundreds of hours of piano, like jazz piano music, and it learned to spontaneously create audio recordings of jazz piano. So you can hear some samples of that. Sounds like Eric Satie or something, someone like that, right? But again, that was completely fake. No human played that. That was produced by a program, which is pretty unreal. And they showed in the blog post. Well, let me get to that in a second. I'll just show you what I have done with it really quickly. One really nice pattern that's emerging is that after these papers come out and demonstrate some amazing new faculty of machines, within days sometimes, some third party independently implements it or reverse engineers it. And so now there's an ongoing repository called Tensorflow Wavenet, which is a number of people. There's now 25, maybe 30 contributors by now, including myself. I've made some contributions to this repository. Lots of people kind of trying to make this stuff escape the walls of these companies. And we're not yet as good as the DeepMind stuff, so I hesitate to even show you this. In fact, I might not, because I trained. Well, let's do it just for the sake of completeness. I'm going to show you a wavenet that I trained on hours of opera, and see if you can hear the sort of like. It's very noisy. Let's just say it's not there yet, but you can hear the sort of some baritone voices in the background, and what sounds kind of like that sound in the beginning of an orchestra, where they're just tuning together, if you can maybe hear it. Oh, yeah, it's horrible, right? That's a wavenet trained on the Barber of Sevilla, and it's a work in progress. So, so one of the cool things about wavenets is that they said, okay, you can play music that is conditioned on some labels that you give it. So for example, if you want to make it say certain words, you condition recordings that are, you have recordings that tell you at every precise moment in the recording what word is being said. And so therefore later, you can ask the neural network to say particular words, which is why you heard the avocado has a pear-shaped, so forth. You don't have to do that though. You can also just ask it to produce anything that sounds like human voice. Doesn't matter what it's saying, just utterances. And if you do that, if you don't provide any labels, this is how it sounds.
Sådan. It was fantastic. Jag still doing but in the button on his totality, Gerald the thing that got killed at school. I'm to us.
Just even. That was this. His lot of work for cadence of determined. That was an A, because I have Jeff over it. It's over to him to be the art day. That here what on.
So I thought it'd be really funny if I tried to run this through YouTube's automatic closed captioning system. You guys know how when YouTube, you can put in an audio record, like a video, and it will try to transcribe it for you. So here I put it online, and this is me going through Google's blog post, the DeepMind blog post to introduce these. and listening to the babble. And here I'm going to turn on the closed captioning right here so we can see what Google thinks is being said. Let me fast forward a bit.
Både nej, kunde jag över. Jag tror över till att bli den arta dig. Där kan jag han.
Det betyder til set now også very sugar offset seed cells behaves. Belangu. He has a head chain we've going to if this was a part.
So they just tag pictures and okay. It's really exciting.
Okay, so you got the idea. This is kind of some fun been having a little bit with these. Okay, so this kind of this is the last let's say scientific part. These are sort of the things that I've been really interested in what happens when these neural networks kind of collide, let's say. And these captioning systems are really interesting also, right? So some software emerged last year from the Stanford Computer Vision Lab, made by Fei-Fei Li, Andre Karpathy, and Justin Johnson, really active in computer vision and machine learning. And they've created software in which a neural network would caption images. So this is a cup of coffee, this is a plate of fruit, this is a fork, a tablet, a bottle of water, a bouquet of flowers. Again, this is all being done autonomously by a neural network, which is describing what it sees in natural language. So that's pretty awesome. So I think like, okay, well, what can an artist find interesting about this? And so I started putting in videos. And the first video that I put was, for those of you who are familiar with the Boston Dynamics Atlas robots, these are these incredible humanoid robots that were made by this company called Boston Dynamics. And they put these videos online. They get like millions of views. I thought it would be interesting to see what DenseCap thought that it was seeing. So here you see this is a white and blue motorcycle, a bike on the rack, a mirror on the wall, a man standing in front of a store, a person on skis, a person on a snowboard, and it really, like, this is the vocabulary it has. It actually never says it's a robot because it doesn't understand what a robot is. It doesn't have that in its vocabulary. And it just kind of goes on like this. It's more sort of bizarre things. I mean, sometimes it gets things right? A brown tree, a tree trunk, a white horse. And of course, I also had to do it on deep dream videos. So here's our famous puppy slogs. 2 dogs, a brown and a white dog. Just dogs everywhere. Dogs. Weird bus. More deep dream junk. And that's sort of like neural networks captioning what other neural networks see. Okay, the last thing, I think I said that last time, but this is the last thing. Style transfer is this technique which lets you recompose one image in the style of another. So here is a picture of the Mona Lisa being restyled by Van Gogh's Starry Night. And it's this, came out in a paper from the University of Tübingen last year, Leon Gattis et al., which really blew everybody's mind when it came out. Just a year and a half ago. No one had really been thinking about this stuff a year and a half ago. And these are just some samples of it. So this is Mona Lisa restyled in Hokusai, in Tarsila, and Google Maps. And this is, you can make video with it as well. So here I've taken a video that I took from the Williamsburg Bridge, and this is kind of overlooking Manhattan. And you see it's like super consistent video frames. This is some research that kind of emerged 6 months ago, made by Manuel Ruder and some others. Again, more Hokusai, and you see the consistency is like really kind of nice frame to frame. I cannot take credit for the software. I wish that I could. This is all open source software that you can use online if you have a really powerful machine that you have access to. And Google Maps, of course, is, I never get tired of using this as a texture. So that's style transfer. And finally, real-time style transfer. This is me being restyled in Kandinsky, you know the Kandinsky sort of painting from the 20th century. Let's just quickly turn this around on you guys. I have a lot of cords sticking out of my computer, so I hope I don't destroy something. Hello, everybody. And actually, this can be done in another style, if I can reach the one key. Now you're in Cubist style. So I made an installation last year called Cubist Mirror. And actually, this can run around 30 frames per second now. I just can't do it on my laptop. But this will be an installation in a couple of days, actually, that I'm going to get to see. OK, and OK. So that brings us to the end. So for me, like, I'm not going to talk about AlphaGo, even though I wish to. But for me, there's kind of something really, really beautiful about this stuff, and especially when I make it approachable, I feel like I'm feel very engaged in this stuff, and so I really am indebted to a lot of people in the research community who have been making tools, making them more accessible, and using them in these really inspiring contexts. So for those of you who are watching the AlphaGo series, glued to wasn't on TV because no one puts that on TV, but for those who are really interested in this stuff, the news, there's a lot of inspiration that we all kind of got from watching the AlphaGo series. That DeepMind created a computer that was an AI which was able to beat the world's top-ranked Go player, Lee Sedol in South Korea. This is a really ancient game, of course, that maybe some people are familiar with. And I love the way that Lee Sedol said, "I will do my best to play a beautiful and interesting game," because I'd never really heard anyone describe a game like that before, or as a competitive game, because I grew up playing chess, and no one talked about chess that way. And for me, there's something really, really beautiful about the way that we are kind of interfacing with these AIs. We're trying to use them in artistic contexts, and we're making them more available to people out there. So I'm really hoping that lots of you stick around and maybe keep up with this stuff online. Please do get in touch with me. I'm kind of always glued to whoever's working with this stuff. It's not a very big community at the moment, but it is growing. And for those of you who are interested in using it, you can find a lot of this stuff on mlforay.github.io, on Twitter, and my website, and all my contact info is there. So please do feel free to ask questions if you're interested. And that's all. Thanks. Do stick around. Oh, I suppose I should ask if anyone has a question.
I have a question. I can speak loud. No, it's because it's online, so even the others, they can hear.
Hi, Gene. Thanks.
Yep.
Thanks for your talk. I always ask this question when artists work with computers. What is your take on the new role of authors, of human authors? So how does this technology impact on authorship, in your opinion?
Authorship in what domain? Like novels or like writers of fiction? Artists?
I created this.
Oh, I see.
They go through all this technology. How does this impact this?
I guess the question that we should be asking is, what does it mean to create? Because that word is not self-defining. I'm always a little, I always see, for me, like, because so much of my work is built on so many layers of knowledge, from computer science to mathematics and, everything on down. I often find that it's very ambiguous, actually, because, all of our work, and I think this is true, actually, for authors, too. Ideas kind of permeate through time. And this, I think, just makes it more explicit, in my view. It just kind of, because it's all in software, so it's very explicit. But I think it actually just carries forward something that's been true for a long time, which is that, originality and creativity are, in some ways, kind of human constructs. I think we're kind of a very innovative species. But authorship is, it's hard to say. It's very hard to define. And I think and now it's going to become even more blurred because a lot of computational tools are actually being used in the assistance of writing. Everything from searching for information online to now there's actually authors who are experimenting, maybe in a tongue-in-cheek way, but still experimenting with AIs that actually write text for them. And the better they get at that, probably in the future, you'll start to see AIs actually creating text that we read, not just as a joke, but actually like for information or for entertainment. So how does that change authorship? I don't know. It depends on what we mean by authorship, I guess.
Hi, Gene. Thank you very much for your talk. I was interested in your opinion on the work that big companies like IBM and the IBM Watson program especially is doing to open the field of AI to developers, just to develop new kind of services. How do you place your work in relation with this, availability of tools from these companies that they want to basically use more crowd intelligence to develop more AI projects?
Well, it's a very multifaceted relationship because, on one hand, because the sort of AI, the field of AI is getting pretty big, but different subsets of it are still pretty small. So sort of this sort of explosion of creative applications of AI is still kind of small enough that a lot of us know each other, and so I'm interacting a lot with departments of some of the companies that you mentioned. I just actually did this work for Google, and maybe it's a nice opportunity to show it. Google released recently this thing called AI Experiments, which has a series of sort of like accessible, where is it? AI Experiments with Google, I think. Oh, there it is, AI Experiments with Google. Yeah. So this is like a bunch of different, so this is made by Google, and actually you'll recognize this video. This is one of the tools that I showed at the talk. And I know some of the other people who made these. These are like little experiments that demonstrate the creative potential for machine learning tools. And Google, this is Google, and Google is very active in exactly the way that you just described. They work a lot in the open source community. IBM a bit less so. IBM and Microsoft are more traditional, so they make sort of like cloud service tools, and they let developers kind of use them. But all of them do participate in the open source movement, which of course, because why not leverage the collective work of all of the developers who aren't on your payroll? And so it's kind of on a case-by-case basis. So I'm trying to create something that isn't necessarily tied to these really large companies, because for them they have many different motivations that I may not necessarily sympathize very much with. And sometimes but it's these companies are complicated. They're also, especially Google, because Google is this very it's a very horizontal company, so it has lots and lots of different components and labs and groups who don't necessarily even know each other, and they're sometimes they're sometimes doing things that I may very much want to support, and some of them I don't necessarily have so much in common with. And so there's no easy way to describe that. It's kind of, again, case-by-case basis. But I think a lot of them, these companies are made of people, and a lot of people share a lot of these, excitement about trying to make these as open as possible. For me, the goal is to make this as open and approachable and accessible as possible. Make it so that you don't have to be, officially tied to these companies or services. And to the extent that those companies are supporting that, then I'm in interaction and in solidarity with them. And in the cases that they're not, then I kind of don't. And just kind of try to promote this more public stuff, open source, and whatever other things that I think support these goals.
Thank you very much.
Over there.
Hi. AI obviously raises a lot of questions about life and also the future of life. And I'm wondering, do you have a favorite definition maybe of what life is, or do you consider that neural networks are life? And
Well, you know, we've been asking that question for way longer than we've had computers, right? And actually, one of a good question is within the biology. You know, people who study biology. I'm not a biologist, so I can't speak about this with much competence. But one question that biologists have is a virus alive? And that's actually very controversial, it turns out, because viruses are, you know, they're sort of lifelike, but they're missing certain features of you know, biological organisms that appear to be part of the definition for life. And so the question is sort of a semantic one, and I'm going to turn it around on you. The question really, like, are these alive? The question depends on what you mean by alive, and that's true for viruses too. So if life is just a word, right? It doesn't mean, it's not it's something that we came up to refer to matter, which demonstrates some properties of what we call life. it's not holy, right? It's just a word. And so it really comes down to the definition. If life has to have the properties of organisms that we are familiar with, then no, it's not alive. If life just means able to process information somehow, then I suppose it is alive. But this question goes back really far, actually. Maybe you're thinking back to Alan Turing, like, you know, who said, "Can machines think?"
Yeah, I mean, there was this debate once between scientists about the chronology of the definition of life, and I didn't realize it was so interesting, and yeah, so I was just wondering, for example, if you also have a favorite definition of life.
I try to be agnostic to definitions, because definitions are, you know, who's to decide? Is there like a special book that everyone can agree is the definition of this and that? I don't know. You know, because we often ask, you know, within the creative AI field, you know, it's like people are asking, are machines actually creative, or are they processing information somehow and doing something that's fundamentally not creative? And really, I don't have an answer. It just depends on what you mean by creative. So Alan Turing asked. So I always love to quote Alan Turing, because for 50 years now, he's been 60 years now, he's been quoted with in the first line of this paper that he wrote in 1950. Can machines think? He's like, I propose to consider the question, can machines think? And he's been quoted that for decades now in every sort of, you know, Alan Turing famously asked, can machines think, and so on. You hear it everywhere. And then if you actually read the paper, 7 pages later, 7 pages after he wrote that question, he said, I consider the question, can machines think, to be too meaningless to deserve discussion. Because he was saying that it's just a semantic question. Thinking is actually, you know, it depends on what you mean by thinking. It's just something that we created to understand what humans are doing with information and, you know, acting upon it. And then he replaced the question with something much more tangible, which was, can a machine imitate that which a human does and convince another human that they are doing what we call thinking? So that's the Turing test. He didn't call it that. He called it the imitation game. And so the question itself is kind of like it's a relativity question. So I hope that's I don't know, that might not be a very satisfying answer.
Is it possible, or how far technology can reach, to make AI have a personality? Their own personality.
So that's a variation of like the Turing test, right? It's like personality would be, you know, if you think it has a personality, right? If you find it personable, there's and people are working on that, right? So like every AI tool, you know, like Siri on the iPhone, and, you know, Google and IBM and all of them have counterparts. They're trying to make it sort of, you know, we want to hear something that reminds us of humans. So, you know, they have human-like voices, and they intonate have intonations like humans, and they say things that are derived from our culture, and so on. And sometimes they're not very convincing, but oftentimes they are. I think right now we're in the sort of uncanny valley, which is where it's like almost human. And if you know what the uncanny valley is, it's kind of that almost human phase that humans find very disturbing, actually. So we love things that are safely non-human, like teddy bears, let's say. We find those very pleasing. But things that are almost human are very, very, like, if you've ever seen like those horror movies from the 90s, like Chucky dolls, and they're always like freak us out because they're like almost human but not. So it's a very dangerous territory. But I think we're trying to create personable AIs, and we're not there yet. But I think in the future we will.
The personality I'm saying is like they can learning by themselves and know what's the things they like and the things they don't like.
So like if they have sort of intention, or they can kind of like, or they can behave autonomously in that sense.
Yeah, maybe.
So not yet really, because those are, we're not really anywhere close to that, because those require much more advanced faculties. Like we can create neural networks that recognize objects and can even say things in some sense, but they're kind of constrained to do a specific task very well. And we haven't really figured out how to make neural networks or machine learning algorithms capable of like higher level reasoning or planning, at least not yet, but there's a lot of optimism that they can. And I'm not sure. I don't know. I think probably it may take a long time because there's a lot of really big hurdles, including things that have nothing to do with computers at all, like climate change. That's going to be a big hurdle for making smart computers. But I think we're on track. Maybe there's no fundamental reason to say that they can't. We're all mechanical in some sense too, I think.
Do you think we are going to create new jobs, or are we likely to lose more jobs?
I think we're likely to lose more jobs.
Thank you.
There's a lot of and we've been losing jobs since the Industrial Revolution. I mean, you can go back to creating machines that work the mills, and right now we're in another period. I think just before a lot of jobs become so some of there's a lot of jobs that are really very close to being ready for machines to take over, like truck driving, for example, which is a huge business of employment in the U.S. At this point, we have the technology to do that really well, and it's just now beginning to get integrated. And that's something that we're going to have to deal with for sure. And there's not, I don't think that the powers that be are really thinking a lot about what to do with these jobs as they become lost. I don't know. I think a lot of people are now, I think for good reason, trying to reevaluate what it means to have jobs or employment, because I don't know if we'll ever, as a species, be able to have like full employment, at least in the sense that we've meant employment for many hundreds of years. Because a lot of labor is now becoming possible to automate. And what we'll do about that, I don't know. I think probably there's proposals for things like universal basic income, and of course there's proposals to do nothing at all. And I think we're seeing the really ugly side of that come out now. I mean, definitely all over Europe and in America, we're seeing what happens when our governments are not addressing this question fast enough. That's my opinion anyway. But yeah, we have to come to terms with this. We're definitely going to lose jobs. By the definition of job that we mean, hopefully humans just begin to occupy, more of the kind of, are able to do more of the things that we don't think of as jobs right now. I think that would be the ideal circumstance, but there's definitely a lot of going to be a lot of transition that needs to happen for that to be done. Mm-hmm.
So you showed your, let's say, roadmap for making this creative machine learning field to make it flourish, to make it bigger, to involve more people, to work on the community and the documentation. So what are the things that you consider like being important to get to this you know, where the community is really large, and how to make this work more, like how to make this more effective in terms of, I don't know, learning and teaching practices. Do you have an idea what is needed to make this field, let's say, not just an experimentation, but make the community working better or interacting better or working on the documentation and all these things?
I have some ideas, and I also recognize that I can't possibly have all the ideas, because AI and machine learning, these are things that I think are constituting almost a new, many people consider, like you've heard this emerge in the last 10 years, that programming is like a new literacy, right? And AI is becoming a big fundamental part of that. And so it's becoming so relevant to everyone that it's affecting almost every sort of aspect of society in some way. And so I can only propose answers in one very limited domain, which is kind of the domain of, like, you know, the creative industries or arts or you know, engineering, because I'm working more on the technical side. There's definitely also a lot of people who I'm following online, I'm in contact with, who are approaching it from a totally different angle, but share much of the same sort of values of trying to make it more something that people are familiar with, can engage with, people who are much more interested in covering the sort of issues that are associated with it, journalists, let's say, writers, people within industry and so on. So the goals are very abstract. For me, the goals are really not any different from the goals that I would attach to anything else, you know, just equity and fairness and approachability, and something that doesn't create sort of barriers between people. So that, I mean, with technology, this is really dangerous. And with this technology in particular, you know, if you have one sort of privileged class of people who know how to use this and have access to the tools, and then the rest of us don't, then that's you know, a recipe for disaster, I think. And I think for me, I'm just trying to counteract that and to try to make more avenues for more people to become familiar with the work. And also to try to scale it. So for me, like, the best thing I can imagine happening is for people to use the resources I put online and to make their own workshops with those resources, or maybe fork them, or things that are copied or taken from them, or, you know, or totally different even, you know. That's the ideal goal, because, you know, one person can only do so much. And I think a lot of people who have a lot of the same sort of abstract goals, you know, approachability, accessibility, but again, you know, maybe not necessarily from an engineering standpoint, but from coming from whatever field that they're invested in. And I know that's sort of abstract, but I try to stay with sort of these kinds of goals and then kind of deduce what needs to be done from that, rather than becoming too focused on, you know, one particular track, and especially with this field, because it's so fast moving, so a lot of the specifics are changing all the time. Yeah.
Okay, thanks.
Mm-hmm. Okay, thank you.